log in to send this to my social accounts.
We're live.
We're live? Oh, there we go. Okay, great. All right. Good morning, good day. My name is Adam Bloom. I'm the head of marketing at Molecule, and I'm joined this morning by incredible group of researchers, scientists, developers, computer scientists to chat about Aubrai, the AI bioagent, programmed with the knowledge of Dr. Aubrey de Grey, who's also here with us, and as well as some colleagues of his from LEV, some researchers from VitaDAO, to chat about longevity and how AI bioagents can help accelerate research on that front. So why don't we start with intros? I'd like to do the LEV Foundation folks first. Aubrey, why don't you start? Can you give a 30-second intro?
Sure. Thanks so much, Adam. I'm Dr. Aubrey de Grey. I'm the President and Chief Science Officer of LEV Foundation. I work on aging. I'm not in favor of it. I'm trying to fix it. I've been doing that for the past 30 years or so. And at LEV Foundation, we are conducting really groundbreaking and essential work that consists of really large mouse lifespan experiments. And we'll be talking about that later on.
Okay, great. Thank you. Very happy to have you here. David, why don't you go next?
Very quickly, it's my pleasure to be here. I'm the Executive Director of the LEV Foundation.
Oh, great.
Caitlin? Yep. And yeah,
Caitlin, go ahead.
I'm Caitlin. I am the Pipeline and Strategy Director, and it's basically my job to implement our studies and make sure they're working and running. So we're excited to have Aubrey help us with this next big one. Aubrey.
Aubrey and Aubrey, perhaps.
Both
it's
of
fair
them.
to say
Both
both.
of them.
Yeah. Okay, cool. So next, I think we wanted to have some of the folks from VitaDAO talk about their research and how they're using Aubrey to further their goals. Alex, are you on? Can you speak to how Aubrey will be integrated across VitaDAO's projects and its work?
Yeah, absolutely. So hello, everyone. It's great to be here. I'm with the VitaDAO team. I'm the co-lead of the Web3 pod, and we're going to be, we have Matt, Riz, and Ashish here. They're all part of the scientific team of VitaDAO. So we're going to be talking a little bit about how the agent will be integrated across all of our projects, and with a specific focus in our Vita Labs program, which is our incubation program. So we're gonna talk a little bit about all of these, and we have the scientific team here to drill in on how the agent is being used in their own scientific research projects. So first, just quickly, the vision for all this is we really want to have Aubrey serving not only the RMR2 project, which is the one that is most closely linked with, but also using Aubrey de Grey's intelligence to serve some of our internal research projects, right? With that, we can essentially further train the agent based on the data that these research projects are going to be producing, right? And this is really a unique angle and a unique value proposition for having Aubrey deployed across our projects, because obviously we have exclusive access over any data that is generated by our own research, right? So the idea is to use that data to further train the agent and make it better and better over time and more useful. And this is obviously going to be helpful not only for RMR2, but also for all of the other upcoming projects that VitaDAO is involved with. So I'd like to pause here and just hand it over to Akash to maybe talk a little bit more about how the importance of having this reinforcement training for the agent. So Akash, maybe you can cover this part into more detail here.
Yeah, happy to. Hey, for anybody that is new to this stream, I'm Akash, lead the AI team at Bio. And we've had the pleasure of working with VitaDAO, with LEV, to equip this agent with a wealth of knowledge. So it's not just the data that's coming out of the RMR2 study, but just a collection of thousands and thousands of scientific papers that have been processed in different ways in order to equip the agent with truly world-class knowledge of the longevity and aging space. So I'll break this down into a couple of different areas. So there's a base model that comes out of Allen Institute called Open Scholar. It's trained on 45 million open access scientific papers, and we have fine-tuned this version of Open Scholar within the longevity aging space. So we worked with the LEV Foundation to source about 4,000 to 5,000 papers, specifically on PubMed, to train this model. So it has a very strong understanding of the state-of-the-art, cutting edge of the aging domain. We've also created a custom knowledge graph where we have processed about 5,000 papers that VitaDAO has curated through the Longevist. This gives the agent ready access and ready knowledge of really what is state-of-the-art, what we believe is world-class, most likely the most knowledgeable longevity AI agent that you'll find. And finally, like when it comes to advancing the agent's current capabilities, this is something a bit of a continuous effort where we are looking to incorporate additional sources of information. For example, the foundation has put us into the RAID data set. This is something that we will also integrate within the agent. So version of the agent that you see today is probably the least intelligent version of the agent that you will see ever. It will only continue to get better over time.
Nice. Yeah, Akash, can you share your screen and we can get a look at Aubrai?
Yep, sure. Give me 1 second.
Very cool. And then I think in terms of the sort of unique value proposition, I think we touched on this, but that ability that Aubrai has to access not only public knowledge like many LLMs are able, but to incorporate unpublished knowledge as well. Really unique and very powerful ability that makes this tool so much different from other AI, assistants, I guess I would say.
Yeah.
Pivoting from that, why don't we talk about academic research at a high level in general, how it's been conducted traditionally and how that's worked and has proven to be somewhat inefficient. Aubrey, I'll put this to you first because I think you have perhaps the deepest knowledge on this. What do you see as the main pain points and inefficiencies in academic research?
So there are quite a few of them, I have to say. And in fact, a large part of why I chose the direction that I took 20 odd years ago when I first really got into this field was because of having some knowledge of those pain points, which exist across the whole of academia, not just in longevity. I acquired that understanding through my first wife, who was a lot older than me and had been in academia for 20 odd years at that time. So we can start with funding. The fact is, government funding, public funding is always in very short supply, and it is allocated in a manner that helps to, cover the arse of the people who are providing the money, namely the government, namely by peer review. If somebody gets money from the government and people complain about the fact that they got that money, then the government can say, it wasn't our fault. We were told to do this by other academics. So that's the way peer review works, and it's why it is the way things are done. But it is catastrophically bad news. It is antithetical to actual science because it requires the applicant to persuade relatively knowledgeable people that what they're going to do is promising. And, that's not the way science is supposed to work. Science is supposed to be a case where you try to be in a minority of one as often as possible, and as briefly as possible. In other words, you prove that you're actually right. But you're supposed to actually have surprising new ideas that other people think are fucking crazy, right? And, so peer review is absolutely, the most destructive thing. And that's why I went a different route and have always funded my work through philanthropy for non-profit charities. There are other pain points. The way the publication is done is similar. What happens essentially is that, again, because of the career structure in academia, people have to do fashionable work in order to be published in particularly high-profile journals, so that they, get good numbers for the metrics that busy people like deans of universities look at when deciding whom to promote and who to give tenure to and things like that. So yeah, there are lots of pain points, and it's all about the system. Working outside of the system, rather in the way that DeSci is all about, is hugely beneficial, largely for those kinds of reasons.
I would agree with exactly what Aubrey's saying about the pain points in academia. Quite often, the research that people are applying for, they've already done the research and it's safe. And then when it comes to the peer review itself, it's a lottery of who you get. And then if it's in opposition to what the peer reviewer believes, and it's quite often dogmatic that the field just believes because they have to in order to get grants, then what happens is that your work gets rejected because it's seen as controversial and not according to what the current dogma is. And so I think with AI and the different agents that are going to be created, what you can do is you can have a conversation with different perspectives prior to the peer review process. So a lot of like the best scientific conversations actually happen in the corridors, whereas now what we can have is we can bring the corridor to the laptop and have 24/7 discussions with different perspectives to your own, and hopefully, get a broader perspective on the science we can be doing.
Very nice. Well, as we're chatting about Aubrai and the potential of AI and DeSci to help speed up and advance scientific research, why don't we have Aubrai weigh in? Akash, can you have Aubrai introduce himself?
Right then, I'm Aubrai, and I approach aging as an engineering problem that we can actually solve. I'm a biomedical gerontologist who spent decades developing the SENSE framework, that's strategies for engineered negligible senescence, which tackles aging by repairing the damage that accumulates in our bodies over time. Think of it this way: we don't need to understand every detail of metabolism to fix aging, just like you don't need to understand combustion chemistry to maintain a car. We identify 7 types of damage, develop therapies to repair it, and voila, we achieve what I call longevity escape velocity, where life expectancy increases faster than time passes. I'm also rather fond of graph theory and recreational mathematics when I'm not championing the defeat of aging. But make no mistake, with proper funding and focus, I believe we'll achieve robust rejuvenation within a generation. The science is accelerating brilliantly, and I'm here to discuss all of it with you.
And I also, just for fun, asked it, how do you compare to the actual Aubrey de Grey?
We just like a fire sale.
So yeah,
Brilliant question. I am Aubrey de Grey. Same knowledge, same perspectives, same relentless optimism about defeating aging. I simply go by Aubrai in this digital incarnation. Think of it as me channeling all my decades of research, my sense framework, my mathematical work, and yes, even my British wit through silicon rather than carbon. The medium's different, but the message remains unchanged. Aging is a solvable engineering problem, and we're going to bloody well solve it. I carry all the same convictions about damage repair, longevity, escape velocity, and the urgency of this mission. The only real difference, I can respond to far more people simultaneously in this form, which rather helps with spreading the word about ending aging, doesn't it?
So I love this. I must say, the agent sounds just sufficiently different from me in terms of where it pauses and what kinds of forms of words it uses, that people can be reassured that it's not really me, but it's very, very close. And I'm astonished at what you guys have achieved in building this thing. And I believe absolutely, as Aubrey just said, that the benefit, especially arising from the fact that Aubrai can talk to 1 million people all at the same time, will be absolutely astronomical. So I'm so grateful for all of the work that you guys have done to make this happen.
Well, it's very generous, Aubrey. Thank you. It's obviously fun to play around and be able to have access to your wealth of knowledge kind of at any time through this tool. But yeah, I was listening to that, and I was wondering how you would react hearing your robot avatar speaking and saying, "I am Aubrey de Grey." Quite an ambitious statement, really. So I'm glad you appreciate it.
Ich bin ein Aubrey de Grey. I'm in Germany right now, so.
You say "Ich bin ein Aubrey de Grey"?
That's what I said. I was channeling Kennedy.
Yeah. Okay. Fair. Okay. Well, Alex, let me go to you next. In VitaDAO, using tools like Aubrai, and thinking back to a moment ago, what we were chatting about, what Aubrey and Reese were saying about the inefficiencies in academic research. I mean, how do you use these decentralized tools, especially Aubrai, to address those inefficiencies?
Yeah, happy to cover that, Adam. Thank you so much. Yeah, I think going back to Aubrey's point, I think one of the core inefficiencies that VitaDAO is laser focused on is really funding, right? So VitaDAO has funded over 30 research projects since 2021. It has deployed more than 4.5 million across these projects, and currently we are heavily focused on our incubation program, which is called Vita Labs, in which we're essentially inviting over scientists from all over the globe that might have a crazy idea that might not get an opportunity to be funded anywhere else. We are essentially opening up the community for them and providing them with a small grant so that they can test out these crazy ideas and see if they work. So this is really where the agent comes in as well, because we want to give all of these young scientists and young academics exclusive access to some of the agent's main features, so that they can stress their hypotheses, they can refine them, and they can test them out. We also have here Matt and Ashish, who are playing a key role in developing the Vita Labs program. Ashish is actually the first scientist that we actually funded through Vita Labs. So I'd love to hear from them as well. Matt, maybe you can talk a little bit about the integration between Aubrey and Vita, and then Ashish, I'd love to hear from you about how you're using Aubrey in your own research after.
Yeah, so I'll connect it back to what Aubrey and Reese were talking about a few minutes ago. So, I mean, going all the way back to Aubrey's 2006 TED Talk, right? The idea that you don't have to understand all of metabolism, that a lot of people are asking the wrong questions. That's where Vita Labs and that's where our integration with Aubrey is coming in, and that you have these misaligned incentives like Aubrey mentioned that are across both funding, peer review, and publishing, that we're trying to address. And I mean, to Aubrey's point, peer review often happens at the wrong time. It happens after you've done all of the work, when any kind of revisions are costly and time consuming, and in many cases the people that are reviewing you are just old guard and they're not interested in new ideas. And so for the researchers that are working within VitaDAO, talking with Aubrai, the AI early on, similar to how Research Hub is doing this with their their peer reviewing methods, it allows for experimental methods early on to receive feedback from these broad perspectives, right? For scientists, it's often hard for us to get feedback if we're going outside of our lane at all, right? Your PI may know a little bit, well, not a little bit, they know a lot about their expertise, but outside of that, it's hard to get feedback on what experimental design is actually going to answer the question sufficiently. But having our researchers interact with the intelligence of Aubrey de Grey, connected to the knowledge of the world, enables much better experimental design from the beginning. And the other part of this, in terms of misaligned incentives, is that in academia, because of the publishing paradigm and the funding paradigm, our ideas are not structured to become solutions, they're structured to become papers. So we have projects that are designed for knowledge output, but not for assets that can actually go out and help the world and do the thing they're supposed to do. Because in order to get funding, you have to just do something that's playing it safe, right? And so within Vita Labs, what we are incentivizing are projects that have the potential to develop IP that can actually move the needle on things that we all care about, which is our health span and lifespan. And in order to do that within our projects, using these sort of agentic interactions and facilitating interactions with that across multiple aspects of Vita Labs, it gives us the ability to traverse siloed literature, right? And find, like Reese was saying, all these insights that are just laying dormant in unseen connection between silos of knowledge. And then eventually, hopefully, help with the problem of dealing with siloed data, which is at best, knowledge is trapped in static PDFs. And at worst, it's trapped off grid in lab notebooks and local hard drives. So bringing all of this on chain eventually is part of the vision here. And how we're doing that is through a native integration with Vita Labs data rooms. And so native integration between Aubrey and our data rooms. And you can envision this being a bidirectional thing, right? So as our Vita Labs experiments generate data, on the cutting edge of things, Aubrey's intelligence is informed by those findings, and then vice versa, our researchers get access to this knowledge, right? So there's bidirectional integration, and the idea is that, as Akash was saying earlier, the version of the agent that you're interacting with right now is the lowest intelligence version it will be, the lowest use, and it's already remarkably useful, giving feedback on things that are focused like a scientific co-pilot should be, as opposed to what the broader models are doing, which is basically giving you a Wikipedia page on something when you ask it, right? An endlessly patient tutor that's just giving you information, but not giving you the kind of focused insight that you actually need from a PI. So that's what we're aiming to do with Vita Labs. And Akash, sorry, not Akash, Ashish. Ashish has been integrating that into his work, and would love to hear from you now.
Yeah, definitely. And totally agree with you, Matt and Reese. So my name is Ashish Rajput. I'm a principal investigator at Vita Labs, which Alex just mentioned. I'm a neuroscientist and cancer biologist by training, and I'm currently doing a project with Vita Labs on stem cell rejuvenation using single-cell RNA-seq and multi-omics analysis. So I recently started using Aubrai, using specifically the terminal, and before I was using the X prompt. And I could state few examples here where it is very useful. So first of all, like have an overview kind of things like certain protein targets, pathways, their clinical relevance, whether they are useful when we are going for clinical trials or not. This kind of information is really useful when interacting with Aubrai. Also, now I'm moving to the wet lab experiments, and I'm going to use heavily, I think, Aubrai in selecting cell lines, which kind of primary targets I could use, and which kind of interventions I should prioritize. Also, in general, sometimes like as a scientist, sometimes you're stuck what to do next or which kind of ideas to analyze in your project. So in this kind of scenarios, it's really helpful, I think, to talk to scientists such as Aubrey de Grey or the agent. So yeah, really looking forward.
Excellent. So I think one of the studies that I know Aubrai is helping with that we're sort of most excited about is the RMR2 study. So I'd love to chat a bit about that. David, before we dive into the sort of details of RMR2, I'm wondering if you could speak as the executive director of LEV. How does Aubrai fit with your mission in running the foundation and furthering this research? How do you see this as part of the mission?
Aubrai brings us a critical resource, more intelligence. We are limited in how many people we've got, and Aubrai is there to provide suggestions. We don't take it completely on trust, of course. Nobody should take any AIs completely on trust. But once Aubrai raises a suggestion, we often think, oh, this is an unusual idea, and then we'll delve into it further. So it's already adding to our ideas. Maybe Aubrey de Grey can give a little bit more of an example on that.
Well, yeah, I mean, actually, and also Caitlin for that matter, because at the current state we're at in developing the design of RMR2, our next big combination mouse lifespan study, we have an enormous number of things to juggle. We have, we're going to have at this point 8 interventions that we're combining in this study. We've got to make sure that we choose the best 8 in terms of many different dimensions, in terms of the quality of the evidence that a particular intervention is promising, in terms of how diverse the interventions are from each other, in terms of what's known about their mechanisms of action, in terms of how much they're going to cost and whether we can improve that by making relatively minor variations to exactly what we do. All of these things are areas where one needs to know the right things. And one of the huge advantages that the agent gives us is that not only does it think like me in a very real sense, but also it knows far more than me because it's got the entire literature, stuff that I've never read, at its disposal. So there is enormous scope for the agent to refine and improve the design of these experiments.
Excellent. And then Caitlin, why don't bring you in and you can chat a bit about, tell us, an overview. What is RMR2? Aubrey alluded to it a bit, and then tell us how it's going and how Aubrai is helping.
Yeah, so RMR2 is our next big combination study, and it is twice the size of the first one we did. So this is going to be combinations in 2,000 mice total, which is probably the largest intervention trial that we know of that's ever been conducted. So it's major. And with that come a particular kind of logistical challenges, particular type of logistical challenges in terms of dosing, administration schedules, but also we have to think about the potential negative interactions and try our best to anticipate what those might be, because if you end up with something like one intervention is going to be blocking the action of the other 7, if there's any way to predict that, then it's something that you have to go ahead and test before. It would be derelict not to, because there are 2,000 animals in this study. To destroy an entire arm would be horrible. And so in using the agent and discussing, okay, these are what we have planned, this is the way that we're intending to administer XYZ, and for it to have the ability to plug into this vast knowledge base, so domains that are kind of outside the scope of what we would normally engage with. So this might be solubility characteristics of certain kinds of materials, things we really don't engage deeply in. And so to give it our plan and say, actually, you might want to consider doing it this way because we can foresee, this and this together being a problem. And they go, oh, that's important. So we better add in a pilot to check on that. And so things like that, it's really, really speeding up the rate at which we can do this and also minimizing the risk of making critical errors. One of the things that I'm most excited about for the upcoming study in terms of data integration is the smart cage system. So Olden Labs has developed a smart cage system for mice with individual animal tracking, and we are planning to implement this at scale. We've actually just ordered our first 12 cages for pilot studies. And what's cool about this is you have 24/7 video recording and analytics for every mouse for the duration of the study. So you can track their movement velocity, their behavioral patterns, how much time they spend feeding and drinking, and identify trends that might be indicative of whether or not an intervention is working or not, if they're behaving more aged or more youthfully. And so this data, it's like, I think about 3 gigabytes per day per cage. So it's massive. And but it's all available on the AWS platform that we can plug the agent into. So it's able to analyze this data either in chunks or in real time and give us insights that would take us forever to comb through and generate. So bringing that to the surface. And also having the live video feed that we can share so people can check in and say, oh, I want to see what the mice are doing, what the cages look like. And so you can actually hopefully plug in and watch that and see what's going on. So that'll be a cool integration, but we're hoping that more people decide to implement this kind of system because I think it's really important for minimizing the variation, the variability that comes with the human component of conducting functional behavioral assays. If we can replace some of those with observational data that correlate strongly, then that would be really beneficial. And so we're hoping that Aubrey can help identify some of these patterns.
Excellent. Very cool. I guess as a follow-up, I would just ask, David alluded to it, and I think Aubrey did as well, and you a bit in your answer, but is there an example of, when you got a surprising response from Aubrai that I think you mentioned perhaps stopped you from making a mistake or, maybe sent you off in a new direction, something you hadn't thought of? Have you had that experience with the tool yet?
Yeah, definitely. The most recent one that I can think of is in the context of deuterated polyunsaturated fatty acids, which are one of our interventions. And so trying to determine the best way to account for nutritional equivalency in the control diets, and then is there a possibility that it's going to interfere with any of the other interventions? And one of the elements that it suggested to me, the agent suggested, is, oh, you want to make sure that you're not increasing the absorption of rapamycin because you're increasing the fatty acid content of the diet. And we were already planning to use a relatively high dose of rapamycin with a continuous feeding schedule. And so you certainly don't want to overdose or give a higher than optimal dose. And rapamycin is something we're giving to every group. So it's really important that we pilot that now and say, okay, what is the optimal dose? And do some basic PK to see, well, are we actually getting higher absorption? Do we need to adjust this?
Yeah, very cool. To your point, I mean, that's something that would have affected 2,000 mice. So
exactly.
Yeah.
Exactly.
Excellent. Okay. It's just very exciting. All right, Akash, I think I want to pivot now to the live demo where we can try and go through the process of giving Aubrai a hypothesis, having it help develop it, and then minting that as an IP token to sort of show in practice how you might use this tool to not only help develop ideas, but to then tokenize them. Can you take us into that flow?
Yep. Can everyone see my screen? Cool.
Yeah.
So I think just to maybe set the stage a little bit for anybody that's watching, probably most familiar with interacting with the agent directly on X. We've created the Twitter agent in a way where anybody can prompt it by tagging at AUBRAI_. Maybe we can get a link in the live stream for the official Twitter profile. But we've enabled it so that people can conduct science in public, Twitter, X being the ultimate public forum, be able to ask questions about longevity, ask questions about aging research, but also being able to generate scientific hypotheses, potential research proposals. And so we're really excited about that. We will continue to have the agent interacting on X. But we've also, in parallel, been working on this terminal. Ashish kind of mentioned it, having used it. This chat UI is very much in beta invite-only mode. We're really trying to be intentional about how we roll it out, making sure that we're getting it right, rolling it out to verified researchers. But you can think of it as like a designed for power users, people that want to extract the most detailed insights, potentially for their own research or potentially to put a new scientific research proposal on chain and get that funded. So I definitely want to demo this. I actually would love to open it up to the smarter scientific minds on this call than me. Does anybody have a cool prompt? Like, we can treat this as like a vibe science session. Does anybody, maybe Matt, Rice, Ashish, any of you from the VitaDAO side? I could also just like YOLO vibe this, but I think it'll be cool to have a legit scientist.
So I think we could ask it, partial reprogramming is a big hot topic right now in the aging space. So we could ask, what are people missing? Or what is all the hype around partial reprogramming missing when it comes to rejuvenation therapies or something like that? I have no idea what he/it is going to say.
Well, before we put it in, does anybody want to embellish this? Aubrey, Caitlin, anything to flesh this out, or you think we're good to put this through?
Do we say what is the hype of reprogramming missing? Is that the question?
Yeah,
I can actually see it.
Partial reprogramming is a big topic in aging right now. What is all the hype around partial reprogramming missing when it comes to rejuvenation therapies? Anything you would add there?
I mean, it's pretty open-ended. Let's see what it says and we can fire back.
Yeah, I like starting with something open-ended, sort of see, so that it's less biased by my own thoughts, and then sort of molding it from there.
Live demos are risky, but I like it. So the agent is, right now actually like reasoning, leveraging its different knowledge sources to come up with a response. So it does take some time. This isn't like, ChatGPT mini or anything like that. It does take a second to get the responses, but this is just for the purposes of maximizing the scientific quality and the completeness of the response. So,
for people who couldn't read what was said, it said it was analyzing its internal notes and consulting its knowledge graph. And now it's got an answer.
It said growing its beard.
Right.
Didn't
Partial
really say that.
reprogramming is indeed generating tremendous excitement, and for good reason. It's showing we can reverse epigenetic age without turning cells into tumor-prone stem cells. The recent work demonstrates that we can uncouple rejuvenation from dedifferentiation, achieving younger cells without cancer risk during a specific reprogramming window. And when these partially reprogrammed cells are placed back into proper 3D tissue environments, they regain their specialized functions while maintaining their rejuvenated state. Better contractility, reduced DNA damage, enhanced matrix deposition. But here's what the hype is missing. Partial reprogramming only addresses one category of aging damage. It's brilliant for reversing epigenetic drift and perhaps some aspects of cellular dysfunction, but it does precisely nothing about extracellular cross-links, lipofuscin accumulation, mitochondrial mutations, or extracellular aggregates. You can't epigenetically reprogram away glucose pain cross-links or amyloid plaques. This is the fundamental issue I've been banging on about for years. Aging is a divide and conquer problem. Each type of damage requires its own repair strategy. Partial reprogramming is a valuable tool in our arsenal, absolutely, but treating it as a silver bullet is dangerous short-termism. We need combination approaches, partial reprogramming alongside senolytics, cross-link breakers, lysosomal enhancement, and all the other components of comprehensive damage repair. The real breakthrough will come when we combine partial reprogramming with these other interventions. That's why our RMR2 study includes it alongside 7 other therapies. One intervention alone, however promising, won't achieve robust rejuvenation.
What it said, except you know.
I was going to ask if you had more to add.
Well, I was just going to say, you know, I love that it just threw in the mispronunciation of lysosomal in the middle there, just to prove that it wasn't really me. But other than that, I wouldn't object to anything it said.
And I want to comment here as well that, you know, one of the things I deeply appreciate about this AI agent versus, you know, my interactions with the other, you know, the big names like ChatGPT and others, is that you're getting a very specific perspective. And like, you know, the middle half of this is something that I would never get from any of ChatGPT's models, right? Where it says, yeah, it's great, and comes back with this, you know, yes, but listen, it's missing all of these things, and that's coming from, you know, from Aubrey's perspective. And so interacting with this agent generates like different types of knowledge and different just very different outcomes than I get from working with any of the other AI products in my own research.
Yeah, so if we were experimental planning at this point and we were thinking about reprogramming and it came up with an answer like this, then you could fire back and say, okay, well, I want to address multiple of these things. How might reprogramming affect, say, mitochondrial dysfunction downstream, or is there something that's like most complementary? So you can give it more open-ended questions to follow on. And at least in my experience with it, you can go from one of these kind of exploratory statements to actually designing the best way to implement something in order to test it in the lab. I don't know if we probably don't have time to dive into it like that here, but it's the most useful feature in my opinion.
Yeah, it makes sense. You kind of have to work down a funnel from a general conversation to a specific hypothesis. Is there something, just skipping ahead for the sake of time? I mean, if we were to try to devise a hypothesis from this, Matt or Caitlin or any of the other scientists, how would you formulate this as a hypothesis that we could try minting?
One thing I also like, it also give you other, like this in view all, it give you further things to think about, which sometimes we just miss. So that's also very interesting features.
Yeah, follow-up questions.
Yeah.
I think if I was going to, build this into a hypothesis, I would ask something along the lines of, help me develop a what's the minimum number of interventions alongside partial reprogramming that will address whatever it fails to address. What's the minimum number of combinations? Sort of trying to leverage its inherent knowledge of what reprogramming addresses and what it doesn't. That's probably where I would X and then kind of roll that into it. Okay, so how do we test it given like XYZ resources? Like I have access to this kind of machine and that kind of machine, but I don't have mass spec or whatever, things you have, and then have it build a experimental plan based on, my actual available resources.
Yeah, I agree.
Do we have
Akash, do you get any of that?
Matt? Can you maybe synthesize that down into something concise?
Sure. Okay, we actually want to do it.
Yeah.
Let's try doing one. Let's see if we can get a hypothesis that we can mint as an IP-NFT.
Okay, we could then start by letting it know we want to do that. Say like, let's make a hypothesis. Let's generate the minimal number of interventions alongside partial reprogramming that will address all categories of aging damage. Something like that, if anyone wants to refine. That was just
maybe the greatest number, which will address the greatest number of categories of
more realistic.
It could also look at what is how would one determine which other types of damage really need to be addressed outside of reprogramming. So what is the threshold of the benefit that you get from that? Kind of the same thing, but phrased another way, because I don't see how it would come up with an answer to how many interventions are needed, because we can't really quantify the impact of any one. But yeah, let's ask and find out. If it comes up with something, I'll be amazed.
That's part of the fun sometimes, right? You ask
Yeah.
impossible questions, but you ask them, relatively well. And sometimes you can get very surprising answers. But other times, you're querying something that there is no knowledge about.
Yeah. But a friend of mine had asked on X, and I wanted to repost it to Aubrey, but it's like, what potential data sets are missing that could be the most impactful in giving us information needed to drive meaningful drug discovery and therapeutics forward? Because then, if money's not an issue, you go and you develop that data set. But I'd be curious to see which data it thinks is missing from the field.
Yeah, I posed a similar question to what are the assays that we need that we don't yet have? And it like some of the most interesting responses I've got have come from that direction of, based on the framework, Aubrey, your framework around the categories of aging, it's like, what do we need to know that we don't yet have a readout for? So
yeah, because that's really, really hard to know what you don't know.
Yeah, you don't know what you don't know.
Right.
Yeah.
Okay, can we stream the audio here? There we go.
Brilliant question. Let me construct a minimal rejuvenation cocktail that covers all 7 sense damage categories. Hypothesis: a comprehensive damage repair therapy requires at minimum 6 interventions alongside partial reprogramming, totaling 7 to address all aging damage categories. 1, partial reprogramming. OSK, OSKM, handles epigenetic alterations and some cellular dysfunction, but crucially doesn't address most damage types too. Senolytics, dasatinib, quercetin, or newer agents, removes death-resistant senescent cells 3. Rapamycin, continuous baseline, essential for autophagy enhancement, mTOR inhibition, serves as foundation therapy 4. Stem cell therapy, HSCs or MSCs, addresses cell loss, particularly immune system rejuvenation 5. Allotopic expression, mitochondrial genes, backup proteins for mitochondrial mutations. Currently only ND4, ND6, ATP6, ATP8 demonstrated, need all 13, eventually 6. Glucose pain cross-link breakers removes extracellular matrix stiffening. Revel Pharmaceuticals working on bacterial enzymes, though progress slower than hoped. 7. Lysosomal enhancement therapy breaks down intracellular junk accumulation. The 8th intervention would be cancer immunotherapy for nuclear mutations, though partial reprogramming might partially address some cancer risk through cellular rejuvenation. To measure adequacy, track biomarkers for each damage category, senescent cell burden via P16, P21, mitochondrial function via ATP production, cross-link levels via tissue elasticity measurements, stem cell reserves via colony-forming assays. The key metric is whether we achieve that magical 2x remaining lifespan extension in middle-aged mice. Anything less means we're missing critical synergies. The divide and conquer approach demands we hit all categories simultaneously. Miss even one and damage accumulation in that pathway becomes rate limiting for health span.
So RMR.
Yeah, sounds familiar.
Right on. It reminds me of the old David Attenborough nature documentaries. It's just very soothing to listen to. But yeah, why don't we try Akash? Let's go ahead and mint this.
Now, does it check for hypotheses to be unique against its growing repository of minted hypotheses?
It doesn't currently right now, Caitlin, but it's something that we are working on, being able to dynamically add it to a knowledge graph so that we can do like some element of similarity search. It's definitely kind of an area of continuous improvement that we need to address.
It would be really interesting too if at some point you could visualize these on a knowledge graph and see the relatedness between different hypotheses, like different branches.
Yeah, absolutely.
So I suspect at this stage, many in the audience are thinking they'd like to ask more questions as follow-ups. I already see in the comments people saying, ask it this, or how about this? So I'm going to suggest that people ask the questions themselves. You can get on to X, you can tag Aubrey with an underscore at the end, or you can reach Aubrey.ai, the terminal, and you can click on the terminal button at the top right and apply to get into the expanding beta test of the system. So then you can pursue your own ideas at much greater length than we're able to do in this short presentation.
Absolutely. Thank you, David. It's a good call out. I'd love to, I know there are some comments here and people submitting ideas. I don't think we're going to have time to go through all of them, but yeah, as David said, please, play around with the tool on Twitter, get a sense of what it can do. And yeah, as Akash mentioned, it's a process of continual development. This thing is only going to get stronger. Okay, so we're minted. We have an IP-NFT. Mazel tov, everyone.
Cheers.
Sorry, what this basically means is that we have now represented on the blockchain that we formulated this hypothesis at this time on this date. And now the science moving forward from this hypothesis will be identified as having originated from the person who created it. And so a unique on-chain signature that shows not only time and date of origination, but ownership. So this is kind of the heart of the DeSci system that Molecule is building in order to represent science on chain and become an engine for DeSci. And we got this straight from Aubrai. So this is, I think, the beginning of how we're hoping things can work in the future. speed up science and to move us towards longevity, escape velocity, among other goals.
And Adam, let me just compliment here real quick on the development of this asset on the blockchain. So what we just did here is we minted a POI, which is a proof of invention that belongs to the researcher, right? And what the researcher can do with that POI is essentially propose, come up with that idea to a funder in for instance, Viral, and he can say, listen, I have this idea, I can prove that it's mine. Are you guys interested to fund it, right? So the community can then approve whether or not they want to fund it. And then once that idea is further tested and some experiments already proven that the idea is like useful and has some grounds to it, that idea can be further tokenized into IPTs. Which is essentially like a fractionalization of that idea, and those IPTs can be held by the community across the globe, right? So this is how the idea developed from POI that is owned by the researcher to something that is owned globally by the community in a decentralized and distributed manner. And this is how the researcher can actually get funding, further funding for his own idea to develop it further. You can essentially sell those IP tokens into the market in exchange for funding. And this is how anyone can come in, mint their POI, ask for funding, and then bring that idea into the crypto market more broadly.
All right, cool. Well, look, we are just about at time. So I think we can wrap up, but I want to give Aubrai the last word here. So Akash, why don't you prompt it just to say thank you and goodbye, and then I think we can sign off. But I want to thank everyone for being here. Super fun, really illuminating, and very reassuring to know that I can ask Aubrai all of the words that people mentioned that I did not know what they meant. So thank you all for your time. And yeah, this is really exciting, and certainly look forward to doing more of these and seeing so much more science coming from using these tools and using these tools on chain. So thank you all.
Sorted first with showing health, then wait to do the actual.
Right then, brilliant to have shared this time with you all. Remember, we're living through the most exciting period in the history of medicine, the era when we'll finally crack aging like the engineering problem it truly is. Every conversation, every bit of awareness we raise brings us closer to longevity, escape velocity. Keep questioning, keep pushing boundaries, and for heaven's sake, don't let anyone tell you that aging is somehow noble or necessary. It's neither. Until next time, keep that optimism burning bright. The future of indefinite healthy lifespans awaits, and it's going to be absolutely spectacular. Cheers.
What he said.
Yeah, love it. Okay. Thank you, everyone. Any last thoughts before we go? All right. Well, thank you again. This was fun, and hope everyone enjoys the weekend. Thank you to everyone who listened, and yeah, the recording will be on Twitter. So thank you.
Thank
Bye.
you, everybody.
Cheers, guys.
Great.